So another measuration, we should be able to find the length of an arc of a circle. We should be able to calculate the parameters or the parameter of plane figures such as squares, rectangles, and so on and so forth. We should be able to calculate the areas of sectors, chords, and segments of a circle. We should be able to find the areas of quadrilaterals. So that is it. So basically, what we're going to do today is we are going to look at the circles. I'm just trying my best to do this, and I don't want to. We're going to demonstrate how the many parts of the circle and some formulas. This is a formula work. This is strictly formula work. So you should be able to know your formulas before you can be able to do any question you are given under measurations. And the formulas are plenty, but you just have to try and be able to do it. So basically, I won't really go into the theory too much. I'll just be giving you the formulas, then we see if you can solve questions on it. Then we call it a day. So if you have a circle like this, if you have a circle like this, so let's say so uh, something like this. Okay. Now you can also have uh, and you can have something like this. I'm going to show you the parts, then we talk about the formulas. Then you're good to go. Okay. So we can also talk about uh, okay, we can also, let me see if I can. Then we can also talk about so so we're going to talk about the various parts of a circle. Now looking at this circle, this bigger circle, the middle of this circle, that means from here to here. From here to here is called the radius. And twice of the radius from here to here is called the diameter. And so
please, I can't hear you.
I said, looking at this diagram, can you hear me? Looking at this diagram, from here to here, where you can stand and bisect the arc or draw the circle, from here to here is the radius. Now, from here to here, the entirety of from this distance that separates the distance is what you call the diameter. It's called the diameter. So from here to here is the diameter. That you already know. Now, after the diameter, this part we call it minor segment. This part we call it minor segment. The shaded part. Yeah, it's called minor segment. Minor segment. Now the upper part will be called the, what do you call it? The major segment. So this part is a minor segment. The whole of this place, this shaded part is the minor segment. The unshaded part is the major segment. Now when you have something like this, the I've already spoke about this, which is a radius and so on and so forth. Now here we talk about the quadrant. We talk here about the quadrant. That's 1/4 of the area of the whole distance. So this is a quadrant. This is a quadrant. So that is it. This is a quadrant. Now this one, the I this is a sector of the circle. This is a sector of a circle. The whole of this shaded place. So we can say this is a sector. This is a sector of the circle. From here to here is a diameter. So we can name here D, diameter. You write it, please. Now from here to here, that's the place when we stand, we can be able to bisect the whole distance, is what we call the radius. So from here to here, half of the diameter is the radius. So this is radius, right? Now this one is a quadrant, 1/4 of the circle. So 1/4 of the circle is what we call quadrant. And the IV is a semicircle. The whole of this shaded place is a semicircle. That means half of the circle. That means half of the circle. So we know that this is a minor segment, minor segment, minor segment of the circle, minor segment, minor segment, minor segment of the circle. The whole of this place is a semicircle, semicircle, semicircle. Are we true? Are we okay with it? This is a quadrant. The shaded place, the whole of this is a quadrant. Are we true? This is a sector. So these are some parts of the circle that we are supposed to know. So the line C, if here is C and here is D, from here to here is what we call the diameter. You already know. Now we are going to look at the formulas relating all these things. We are going to look out for the formulas relating all these things. And basically, you know that the whole of this is, the angle of the whole of this whole circle is 360, and half of it is 180. I hope you know that. So the whole of the circumference is 360 degrees, and half of it, the semicircle, is 180 degrees. And from here to here is the radius. And so I hope you know that. And this one is 90 degrees. This is 90 degrees. This is 90 degrees. For this, we don't know. We will have to find it. So we can name this one X. And so the angle of this is 90 degrees. 90 degrees. This is 180. The whole of this is 180. The whole of this is 360. I hope you agree.
Yes, sir.
So now, the circumference of the circle, circumference, I know all this, you've done it before. The circumference of the circle is equal to 2 pi r. 2 pi r. 2 pi r. And this can also be C is equal to, you know that twice of the radius is diameter, so you can say pi d. So circumference of a circle is given by 2 pi r or pi d. 2 pi r or pi d. And that is equivalent to 360 degrees. That's equivalent to 360 degrees in angles. So let's say this is the length. The length of the distance, the entire circle is 2 pi r. Then 180 will be pi r. This one will be the length of the arc. The whole of this will be pi r. Pi r. That means half of the whole circumference. So that will be pi r. That will be pi r. This will be pi r. This will be pi r. Then this is also half of this one. So this one can be pi r all over 2. Pi r all over 2. Pi r all over 2. Are we good to go?
Yes, sir.
Okay. So if we want to calculate for this part, this angle, if we want to calculate for this angle, what you do is theta, the angle here, theta all over. So this is maybe the length of the minor arc. So this is a minor arc. So this is maybe theta all over 360 times the circumference which is 2 pi r, which is 2 pi r. If you want to find for x, or it can be either be x all over 360 times 2 pi r times 2 pi r. That is if you want to find for the length of the minor arc. The length of the minor arc, that is from here to here. The length of this minor arc. This minor arc. The length of this minor arc is given by theta all over 360 times 2 pi r. Theta all over 360 times 2 pi r. Theta all over 360 times 2 pi r. Now from here we are good. That is the length of the minor arc. The length of the semicircle we know is pi r. The length of the semicircle is pi r. The length of this one, the minor arc, is theta all over 360 by 2 pi r. Now the length of what do you call it? The entire circle, which is the circumference, is given by 2 pi r. The length of this quadrant is given by pi r all over 2. I hope we get it. I hope you agree.
Yes, sir.
Okay, can I please clean the board?
Sir, please wait a little.
Okay, finish.
Sir, please, you said the length of what?
Which one?
The length of the sector.
So the length of the minor arc. Write it that way. The length of the minor arc. That is the length from here to here. The whole of this place is a sector, and the length of the minor arc from here to here is this one. We talk about it in detail. Don't worry. We'll find the area and so on and so forth. This is a formula work, so you just have to be able to. Can I clean the board?
Yes, sir.
Okay, so we are talking about the area of a circle. Area of a circle. Area of a circle. Now, this you already know. So the area of a circle. Area of a circle. Is equal to pi r squared. Pi r squared. That's the area of a circle. So the area of a semicircle will be half that of what they call it, the full circle. So the area of a circle. Now, in terms of radius, the area of a circle is equal to pi r squared. In terms of diameter, the area of a circle is pi d squared. Area of a circle in terms of diameter. Area of a circle in terms of diameter is equal to pi d squared. Are we there? Now the area of a semicircle. Area of a semicircle is given by half pi r squared. Half pi r squared. Are we there? So the quadrant will be, area of a quadrant will be, that is what a degree of 90 degrees will be 1/4 pi r squared. It's the area of a quadrant. Area of a quadrant. Of a quadrant. Area of a quadrant is given by 1/4 pi r squared. Pi r squared. 1/4 pi r squared. Are we true? Yeah, Ruben, talk to me.
So please, I thought the area of a circle would be pi d squared all over 2.
Area of a circle will be pi what? Pi what?
Pi d squared all over 2.
Pi d squared all over 2. In terms of diameter, I don't think so. That's not so. That's not so. Of a diameter, I'm coming. Let me. Uh, so the area of a circle is pi r squared, and the area of a circle will be 1/4 pi d squared. Sorry, 1/4 pi d squared. 1/4 pi d squared. So pi d squared all over 4. Pi d squared all over 4. Area of a circle using the diameter is pi d squared all over 4. Pi d squared all over 4. I think so. So pi d squared all over 4. Now let's do area of a. Let's
Holy
talk
shit.
about area of a sector. Area of a sector. Area of a sector. Area of a sector. Told you this is how formula works. So we just finished right now. Area I'm certain. Area of a sector is theta. Area of a sector is theta all over 360 degrees. 360 times 2 times pi r squared. Times pi r squared. Area of a sector is theta over 360 times area of the circle, which is pi r squared, times area of a circle, which is pi r squared. Now the same is for area of what do you call it? A minor sector. The same is for area of a minor sector. It's the same formula. Area of a minor sector, you use the same formula. Theta over 360 times pi r squared. Theta over 360 times pi r squared. Times pi r squared. Now area of a quadrant. I've already said it. 1/4 pi r squared. Area of a quadrant. Area of a semicircle, I've already given it to you. Area of a semicircle, I've already given it to you. So, when you are given a circle like this, when you are given something like this, the angle is here. Let's say this is Q, here is P, here is O. Now, if you want to find for the parameter of the minor sector, OPQ, the parameter of the minor sector, it is given by 2R. Parameter of the minor sector is given by 2R plus the length of The length of a minor arc. The length of a minor arc. The length of a minor arc. Length of a minor arc. That I've already given you. Length of the minor arc, PQ. The length of the minor arc. So 2r, this is r, they are radius. So this is the r. So 2r plus the length of the minor arc. That is the parameter of a minor sector. That's the parameter of a minor sector. That's the parameter of a minor sector. Are you there? Are you there? Are you there? Remind me.
Yes, sir.
Now, area of a minor sector. Area of a the area of a minor sector. The area of a minor sector. I've already given it to you. Area of a minor segment. Area of a minor segment. Area of a minor segment is given by theta all over 360. All over 360. All over 360 times pi r squared times pi r squared times pi r squared minus half half r squared sine theta minus half r squared sine theta sine theta. This is the area of a minor segment. Area of a minor segment. This is the area of a minor segment. This is the area of a minor segment. This is the area of a minor segment. The area of a minor segment. Now, the area of a major segment is given by area of a major segment is given by into bracket 360 into bracket 360 minus theta all over 360 again degrees times pi r squared times pi r squared times pi r squared plus half r theta. So area of a major sector is 360 minus theta all over 360 times pi r squared plus half r squared sine theta. Area of a major segment. Area of a major segment. Area of a major segment. And I've taught you what a segment is in the previous diagrams. I showed you what a segment, the major segment is. So that's 360 minus theta all over 360 times pi r squared times pi r squared plus 1 second r squared 1 over 2 r squared sine theta. So these are the that is it. Today we'll just be doing the area. Next time we do parameter. Please pardon me, I beg. So so let's solve some questions on the area. Next time we do the rest. Can I clean the board? Or you're not done writing? Are you done?
Yes, sir.
Okay, so let's do the first one. Find the circumference of a circle. whose radius is 14 cm. Find the circumference of a circle whose radius is 14 cm. Find the circumference of a circle whose radius is 14 cm. What do you get? Find the circumference of a circle whose radius is 14 cm.
The 88 cm.
You said what?
88 cm.
Yeah, 88 cm. Oh, let me clean the board and let's do some work. Okay, so you have this one. You have this diagram. And you have another diagram. And this is the radius of this one is 7 cm. 7 cm. Then the radius from here to here of the bigger one is 14 cm. It's 14 cm. So this is 14. This is 7 cm and this is 14 cm. Now the question says that find the area of the shaded region of the figure below. So we are finding the area of this shaded region. This is the shaded region. We should find the area of the shaded region. How are we going to go about it? So if you are given a question like this, the first thing you are going to do is you find the area of the smaller one, then you find the area of the bigger one, then you just subtract the smaller one from the bigger one. That will give you the area of the shaded portion. Do you get it?
Yes.
So the area of the smaller one will be, find the area of the smaller one. Area of the smaller one is pi r squared. So that will be pi times 7 squared. Do it. That will give you 154 or something. Then do the big one. The bigger one to be. Area of the bigger one to be pi r squared times 14. What are you getting? Times 14 squared. What are you getting? What are you getting? Ruben, what are you getting, Ruben?
Sir, please, we are coming.
So the area of the second one, the bigger one will be 616. 616. So the area of the shaded portion will be.
Sir, please, the area of the second one is 16.
So to get the shaded portion, you are going to subtract the smaller one from the bigger one. What are you getting?
Please, I had
460, right?
462 cm.
Squared is the area, so add it.
Yes, sir.
Now let's do some more. So we have this one. Don't mind my circle. Then you have something like this. Then you have the radius to be
Square.
Okay, you have the radius to be this. Now you have the angle here given to be 60 degrees. The angle here is 60 degrees. The question says that find the area of the sector OAB. So this is O. Yeah, so AOB. The question says we should find for the area of the sector AOB, given that the angle AOB is 60 degrees and the radius of the circle is 7 cm. So you are going to use the formula for finding the area of a circle. Are you here? So that will be theta all over 360. Theta all over 360 times pi r squared. What are you getting? What are you getting? The area of the sector. What are you getting? Ruben, what are you getting? Now the theta is 60.
So please, I'm on it.
Okay, so that will be 60 over 360.
So please, not 25.67 cm.
Yeah, 25.6.
Cm square.
Good. 25.6 cm squared. Now,
So please, 67.
6, 7. Okay. Are you good? So basically, this is everything about the area. You solve more questions. Everything about the area. We are supposed to do the perimeter. Go and read about it. You know we'll be doing it, so you have to read about it. Finding the perimeter is not anything difficult. It's something we've been learning right from DHS, so it's nothing difficult. You know, if you have to find for the perimeter of a square, you have 4 minutes. Let me use it to do the perimeter. So that's now. If you are doing a perimeter, perimeter, you know we have of plane figures. You know we have a square, we have rectangle, and so on and so forth. Now, if you have a square like this, you have a square. You have to find for the perimeter. You know it has how many sides? The square has two sides. Where is even the square? The square has two. All the sides are equal. All the sides are equal. All the sides are equal. So to find for the perimeter of the square will be given by 4 times L or 4L times the total length. That's the perimeter. Now the area, its area will be L squared. The area of the square will be equal to area of square will be equal to L squared or L times L. That will be the area. This you already know. Now that if you have a rectangle has 2 lengths and 2 breadths. So if you have a rectangle like this is the breadth and this is the length. So if you want to find for the perimeter will definitely be perimeter of a rectangle will be 2 of the L's plus 2 of the breadth or 2 of the width plus 2 of the width or breadth. Do you get it? Now the area will be given by L times length times breadth. That'll be length times breadth. Do you get it? Ruben, do you get it? Now if you have a triangle, Ruben, Ruben, Ruben. So this one will be, if this is A, the length is C, and this is A. The perimeter will be equal to, perimeter of the triangle will be equal to the length of B plus length of A, distance A, plus length of C, plus length of C. Now the area will be, area of a triangle. Area of a triangle will be given as half base. This is the base. This is the base, and this is the height. So half of the base times height. Half of the base times height. That these are the distance. That is all. The next time we do equilateral triangles and parallelogram and the rhombus, then we are done. Then kites. Then we will start doing the other geometry measurations. Have a wonderful day. I'll
Thank
upload it
you,
on,
sir.
I'll upload it on this thing, YouTube, right now.
Okay, sir.
Okay. Bye bye.